Let's continue multiplying fractions. So problem C is another great problem to do in class. So Ray made a tray of brownies. He ate 1/5 of the tray after they had cooled. The next day he ate 3/4 of what was left over in the tray. How much of the whole tray did Ray eat the next day? So it seems simple enough. Let's draw a picture. So here's the tray. And he ate 1/5 of the tray after it cooled. So that's what he ate. So notice we shaded what he ate, but then next it talks about he ate 3/4 of what was left over in the tray. So now this is what we're using as our unit to find 3/4 of this amount, which is 3/4 of 4/5. Okay, so one thing your students may notice, which would be fantastic, is that if we take 3/4 of what remains, if we're thinking of this as our unit, there's 4 pieces, and 3/4 would be 3 of these. Okay. Now notice this is where the unit and our reference of measurement really comes into play. How much of the whole tray did Ray eat the next day? Well, it's tempting to now look at this and say, hey, I just found it 3/4, but it's 3/4 of what was left over. Now we want to find this amount relative to the whole tray. Okay, and you can see that relative to the whole tray, this is 3 out of 5 equal pieces. Okay, so in terms of multiplication, they're given 1/5, but you know, if they just went to multiply this without thinking about it, they might choose 1/5 instead of 4/5. So 4/5, and we're taking 3/4 of 4/5. I should have written that first, but you get the gist. Multiplying, we have 12 over 20, and also notice if you simplify first or later, this is 3/5, which was our result. Now another way to look at this, because this one's kind of special, the way that what remained was 4 equal pieces, so it was easy to find 3 out of 4. But let's just look at kind of what we did with the area model. Okay, so this will always work. So let's break it into fifths this way. Okay, and now we want 4/5, okay, is how much is left over. Then 3/4. So now I'm going to split in the other direction of this. So now this is split into quarters, and he had 3/4 of what was left. So now notice, here's the 4/5, here's the 3/4. This is the intersection of the two. Okay, so looking at it this way, now they could see there's 20 equal pieces, and he ate 4 times 3, or 12 of them. Okay. So that will show the connection between the original multiplication if you don't simplify first, and it's important for them to see that. So 4/5 times 3/4. So I know we love to simplify first and get the results of 3/5, but sometimes that helps them or makes it more difficult for them to see the connection between multiplying the numerators and the denominators and what it means in terms of the unit. Okay, let's look at, next we have multiplying mixed numbers. Okay. And this first problem is a nice problem because it's using multiplying by a mixed number where the number is a scalar, so something is times as large as. It's dimensionless and unitless, so let's just read and I'll explain more. According to the Bureau of Labor Statistics, the buying power of the dollar is 1 4/5 times larger in 2016 when compared to 1991. Determine the comparable buying power in 2016 of $10 in 1991. Okay, so, well, here is 1 4/5. So this whole thing would be shaded. Pretend these are equal. Okay, so this is 1 4/5 representing this mixed number. Now we want to think 1 4/5 times as large as 10. So then we can think about, well, this is 1/10. Now we have this broken into 5 pieces, so each one is $2. Okay. So 1 4/5 times 10 would be 10 plus these for $2, or $18. Okay. So notice that when we multiply 1 4/5 times $10, okay, here what I meant before about 1 4/5 being a scalar or dimensionless, notice that this doesn't have a unit of measure. This isn't referring to dollars or anything else. It's just 1 4/5 times this dollar amount, and our result would be $18. Okay. So you could think of this in terms of percent increase, which we'll cover in a later section, but that's one of the reasons this will be important. Or just something times as large. So I saw in the news the other day that BPen used to be $100. Now they're charging $600 for it. Okay, so the new price is 6 times as large as the old price. Okay, and notice that 6 is dimensionless. You're just multiplying the $100 times 6, as opposed to a rate where you'd divide dollars divided by days or something where there's 2 different types of units, or another unit. Okay, and then also later we'll see they'll talk about this being a 500% increase, but that's eventually where another spot where we may need this. This next one is a little bit painful to draw. I remember it being painful in the video and wishing I hadn't put it in there, but it was too late. But the idea is important. Okay, so now we have mixed numbers. We're multiplying 2 mixed numbers. Okay, and again, typically as a strategy for this, we tell them rewrite it as improper fractions, then multiply, and then change it back to a mixed number. And the reason we do this is we know that 2 3/4 means 2 plus 3/4. This means 3 plus 5/8. So when we're multiplying these, they're tempted to just multiply the whole numbers, multiply the fractions, and then they're really missing those 2 other products. So this can show that nicely. Let's make this 2 3/4. Okay, so I didn't get too specific here. So this would be 1, this is 1, this is 3/4. Up here we have 3 5/8, so 1, 2, 3. 1 here, 1 here, 1 here. And we'll say that's 5/8. Okay. And then if we cut these up, we can see that each one of these is 1 mile by 1 mile. So 1, 2, 3, 4, 5, 6. And notice that's our 2 times 3. Here we have 1 by 3/4 for 3 of them. And that is our 3/4 times 3. Up here we have 2 by 5/8. And that's our 2 by 5/8. And then our last product would be 3/4 times 5/8. We'll just multiply that. 3 times 5 is 15. 4 times 8 is 32. Okay, so cutting these into pieces can really be tedious, but the important thing that this diagram shows is it's not just 2 times 3 and then 3/4 times 5/8. You need to include these pieces. Okay, so them seeing this helps connect to the idea that you're not just multiplying the whole numbers and the fractions, okay, and that there's really this idea going on, which I try to remind them of constantly. That this product really means this, and since this is in parentheses, we can add this, but 2 3/4 is our representation of that. So rewriting this as an improper fraction, And what's that, 29 over 8? Okay. Eliminates the addition and the need to use the distributive property there. Okay. And here are some more practice problems, and in the next video we'll look at dividing fractions.